Good morning, students. Last class we are discussed about that de Broglie wavelength, right? So today let us discuss about related to the de Broglie waves. It's this experiment is a Davidson germer experiment. Okay, it is important one. Coming to the 3-mark questions or 5-mark questions. Okay, you see that de Broglie hypothesis of the matter waves was experimentally confirmed by the Clinton Davidson and Lester Germer. So what the both of them doing means the de Broglie wavelength experiment மூலமா explain பண்ணிருக்காங்க. Okay, in the 1927 they demonstrated that electron beams are diffracted when they fall on the crystalline solid. Okay, they are given to the demonstrate. What demonstrate means that the electrons beams are diffracted diffracted when they fall on crystalline solid. The electrons எப்போ நம்ம crystals fall ஆகுதோ அப்போ it's a electron beams diffracted. Okay, so since the crystals can act as a 3-dimensional, so when that times it's a crystals act the 3-dimensional diffraction grating for the matter waves. It's giving the greater, okay, grating. So the electrons waves the incident on the crystals, the electron waves incident on the crystals are diffracted off in certain specific direction. So what happened when that the electron waves incident the crystal that diffracted off in the certain specific direction, the specific direction of agum. Okay, so that is a given to that experimental. Okay, you see that this is that what a low battery, it's a high battery. This is the filament cathode. Okay, filament cathode. So this is the cylinder, one cylinder. This is the aluminum cylinder. This is the anode. This is the beam of rays. Okay, incident beams. So you see that this is the electron gun. So this is the white color having no, that is the electron gun. Okay, this is the nickel prism. Okay, so it's a scattering of beam. So this is one the electron detector. This is the electron detector. First what we are doing means you see that here that a low battery, so the filament F is heated by the low tension battery. So the low tension battery produce the current to that filament. Okay, heat பண்ணுது. The low tension battery heat to the filament. Okay, heat to the filament. Then the electrons are emitted from the hot filament. The hot filament emitted to the electrons. Okay, emitted to the electron by the thermoionization. The thermoionization. Okay, thermoion emission. Okay, they are then accelerated due to this. So this electrons accelerated due to the acceleration due to that aluminum cylinder and in between of the filament and aluminum cylinder. This is a anode to the cathode. It's a accelerated to the in between of the filament and the cylinder. So the filament whenever that lower tension is produced to the heat, it is heat to that filament. Okay, the hot filament make to the heat to the filament. The hot filament produced to the electron. Okay, produced to the electron. Then it's accelerated due to in between of the filament and the aluminum cylinder. Okay, so then that electron beams is collimated by the using two thin aluminum diaphragm. So the two thin aluminum is what doing the collimated the electron beams. The electron beams are collimated pannom. Okay, it's collimated by the aluminum diagrams. So allowed to the strict the single crystal of the link. So this is allowed to the incident of the beam. So the incident, it's allowed to the incident of the beam to the nickel crystal crystal. The nickel crystal incident ஆகும். After it's a reflected the scattered beam. So after it's a reflected to the scattered beam, after the reflected to the diffraction, after deflected to the scattered beam. So next it's a received by the electron detector. So this scattered beams received to the electron detector. So what doing that electron detector? It is measure the intensity of the scattered electron beam. So in the nickel crystal is reflected to the scattered beam. That electron detector is collect the scattered beam. What it is doing now, it should measure to the intensity of the scattered beam. It measure to the intensity of the scattered beam. Are you understood? Okay. So next you see that the beam of the scattered. So it is that the detector, the electron detector is rotating. So they can able to the rotate. It's able to the rotate that. So the plane mirror of the paper, so that the angle pi between the incident beam, the beam and the scattered beam can be changed at our will. Okay va? So our will wish only, it's a change. The intensity of the scattered electron beam, the intensity scattered, it's a find out the electron detector find out the intensity of the scattered beam. It's measured as a function of the angle of theta. So you should measure to the angle of theta. Okay, so you see this angle, we are put one graph. This is the angle of theta. X-axis we are mentioned to the angle of theta. Y-axis we are mentioned to that diffraction electron beams, intensity of the electron beam. Okay, so next you see that the scatter wave show the peak or maximum at the angle 50 degree to the incident electron beam. This peak is the intensity attributed to the constructive interface of the electron diffracted from various atomic layers. So the various atomic layers they diffract in the target of the material from the known value of the interplanar spacing of the nickel. The wavelength of the electron wave has been experimentally calculated. So the wavelength of the it's produced to the wavelength of that electrons, which one by the nickel prism. Okay, so that calculated means 1.65 Armstrong. The wavelength can be also be calculated from de Broglie relation. So how to we are calculate the wavelength? It's a relation to the de Broglie wavelength. So V equal to 54 V from equation. So lambda equal to 12.27 divided by, so last class we see that lambda values we are find out on de Broglie wavelength 12.27 divided by root of A Armstrong. So the V order value we have to find out here the 54. So you have to apply to the 54 and calculated that lambda equal to 1.67 Armstrong we are get the value. The value agrees well with the experimental observe the wavelength of the 1.65 Armstrong. Thus the experimental directly verify the de Broglie hypothesis of the wavelength nature of moving particles. Okay, are you understood this? So this important one, it's coming to the 5 marks or 3 marks. Okay, so next you see that my electron microscope. So next one is a electron microscope. What you are doing, which one is constructed, how to is constructed to the electron microscope means the wave nature of the electron is used. The wave nature of electron, that principle only used in the construction of the microscope. Adho use பண்ணி தான் microscope construction பண்ணிருக்காங்க. ஓகேவா? So this is we are said to be electron microscope. This is we are said to be electron microscope. Okay, resolving power of a microscope is a inversely proportional to the wavelength of the radiation. Okay, resolving power. So resolving power of the microscope, what here using the power of microscope inversely proportional to the wavelength of the radiation. எப்படி இருக்கும், அதுக்கு inversely proportional இருக்கும். resolving அந்த பவரை ஃபைண்ட் அவுட் பண்ணுறது எப்படி இருக்கும்னா, அந்த எலக்ட்ரான்ஸ் பீம்ஸ்லேருந்து வர அந்த ரேஸ் வந்து அந்த ஒளிக்கற்றைன்னு சொல்லுவாங்க, அந்த ரேஸ், அந்த பீம் ஆஃப் த ரேஸ் எப்படி இருக்கும்னா இந்த இன்வெர்ஸ்லி ப்ரொஃபஷனல் டு த வேவ் லென்த்தாக இருக்கும். இன்வெர்ஸ்லி ப்ரொஃபஷனல் டு த வேவ் லென்த்தாக இருக்கும். த ரேடியஸ் யூஸ் டு illuminate the object under the study. Higher magnification as well as the higher resolving power can be obtained by the employing wave the shorter wave. ஸோ ஹையர் மேக்னிஃபிகேஷன்ஸை நீங்கள் யூஸ் பண்ணிங்கன்னா, ஹையர் ஷார்ட்டட் வேவ்ஸை நீங்கள் யூஸ் பண்ணிங்கன்னா ஹையர், அதாவது அப்போ அந்த மேக்னிஃபிகேஷன்ஸும் இப்படி இருக்கும், ஹையராக இருக்கும். ஸோ யூ ஹாவ் டு யூஸ் டு த de Broglie வேவ் லென்த் வேவ்ஸ். de Broglie வேவ்ஸ் வந்து இட்ஸ் a very 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 small only. That wave you have to use into the microscope means it is here that object the magnification is here very high only. Okay va, that is they are set here. So de Broglie wavelength of the electron is very much less than, so that one we have to using here that optical microscope. The microscope employ de Broglie waves of the electron have very much higher resolving the power. So அந்த resolving power எப்படி இருக்கு, ரொம்ப ஹையாக இருக்கு. ஓகே, ஸோ ஆப்டிக்கல் இதில் ஆப்டிக்கல் மைக்ரோஸ்கோப்பில் the electron microscope gave magnification more than 2 lakhs. ஸோ இது மாதிரி de Broglie waves we have to use means என்ன ஆகுனா 2 lakhs டைம்ஸ் என்ன ஆகும், அதனுடைய மேக்னிஃபிகேஷன், இந்த ஆப்ஜெக்ட் மேக்னிஃபிகேஷன் இருக்கும் அப்படின்னு சொல்கிறாங்க. ஓகே, திஸ் அண்ட் ஆல் வி ஆர் யூஸிங் டு த லெபார்ட்ரி ஒன்லி, ரிசர்ச் லெபார்ட்ரி ஒன்லி. திஸ் டைப் ஆஃப் த மைக்ரோஸ்கோப் வி ஆர் யூஸிங். How to this construction? You see the next construction. The construction and working of the electron microscope is similarly to that of on the electron microscope and expert to the electron optical microscope. You see this, the first picture is here, this is here optical microscope, this is here electron microscope. You see the similarly having that, but the small variation of the wavelength, the diopter, okay, on the lens. You see that next one. So next, then the electron beams passing across a suitable arranged either the electric or magnetic field undergoes the divergence or convergence theory by focusing of the beam is done. So இதனா ஆகும், diverge ஆகும், converge ஆகும். We have to using to the optical electrical magnetic field. Okay, so என்ன பண்ண, இந்த magnetic field இந்த lens என்ன ஆகும், divergence பண்ணும், convergence பண்ணும். Okay, the electron emitted from the source are accelerated by the high penetrates. So electron emitted from the source are the accelerated high penetrate இருக்கும். So the beam is made parallel by the magnetic consider lens. So இந்த parallel beam எப்படி அது consider பண்ணா, magnetic consider lens மூலமா அது வந்து it's made of the parallel produce பண்ணுது. When the beam passes through a sample whose magnified image is needed, the beam carries the image of the sample. Okay, with the help of the magnetic objective lens and magnetic projector lens system, the magnified image is obtained on the screen. This electron microscope are being used the almost all the branches of the science. This type of the electron we are using to that branches of the science only. Okay, are understood? Thank you children.